Hello and very warm welcome to all of you. In today's session, we're going to use Ka to rank acids and bases. The first question I have provided for you is rank this from the strongest to the weakest acid. And these are the four acids that I have. I went ahead and I put the Kw, usually this Ka, usually this is given to you from a table. And let's see if we can rank them together. The higher the Ka, the stronger the acid, so the first one should be straightforward. The strongest one is HClO4, which is carperchloric acid, followed by HClO2, according to Ka, which is called chlorous acid, and NH4, ammonium, with the M at the end, and water. Very straightforward. Looking at the Ka, rank them. The higher Ka, the stronger acid. The second question, it says rank strongest to the weakest base. If you pay a little bit close attention, you notice that the second one, or conjugate base of the conjugate base of the acids from the first question. The rule of thumb is this: the stronger the acid, the weakest the conjugate base. Usually I ask my students to rank the first and the strongest and the weakest one. So with regard to the Ka and Kw, if you calculate Kw, you notice the weakest one is NH3, the strongest one is NH3, my apology, and the weakest one is ClO4 minus. Pay close attention where water falls into this. This is followed by ClO2 minus and water right here. I wrote a note at the bottom of the screen that for water, use Kw, which is 1.0 times 10 to the negative 14. Sometimes it helps you understand when you go from strongest acid to the base, that's where water falls from. There are some rules that are useful. The first is the weaker the acid, the stronger the conjugate base. And the next two are just observation. These are the conjugate base of the first example, and NH3 has a lone pair electron, is a Lewis base. So it's a rather powerful base. Anything with a nitrogen, except if it's a quaternary nitrogen. Anything other than quaternary nitrogen are bases. They have lone pair electron. The last two are very important. Conjugate base of a strong acid is extremely weak base. Notice in here, ClO4 minus became the weakest base because was conjugate base of such a strong acid. HClO4 is very strong. And the last one, conjugate base of the weak acid, is a weak base. So if it's a weak acid, falls in a weak base. Strong acid conjugate base is weak. Strong base conjugate acid is weak. I hope you practice on this. This is very important and useful. Let's practice a little bit more. I highlighted a few items, just HCl and H2O. Which one is the stronger acid? Couple of things to consider when you answer this question. Water is something you drink, is neutral, so it cannot be acidic or basic, whereas HCl is very acid. Either use the common knowledge or know the value of Ka. Strong acids, as I highlighted in the previous session, have very large Ka, whereas water we use 1.0 times 10 to negative 14. So I'm just going to circle it, HCl. Followed by H2O, HNO2, nitrous acid. It's an acid, although it's a weak one, but still is an acid. Either use that common knowledge or use the fact that Ka is greater than Kw for water. Remember, for water, use Kw. HCN or HOC6H5. For those of you who know organic chemistry, it is one of my favorite topics. I'll start recording some sessions for organic chemistry. This is called phenol, and this hydrogen is acidic hydrogen. By looking at the Ka, this you need to have Ka, otherwise a little bit difficult. You notice HCN is a slightly larger number than Ka for phenol. Let's switch to strong base. Again, these are reflection of the top equation, Cl minus versus H2O. In this case, Cl minus is a conjugate base of a strong acid, so it's very weak, and I denoted this by less than 10 to the negative 14. So in this case, water wins. H2O and NO2 minus, again NO2. I calculated Kb for you here. You can just divide 10 to the negative 14 divided by Ka, you get Kb. So this is a stronger base. And the last two, if you pay a little bit close attention, there is a correlation between these two. Let's see if I can draw it. These two. HCN was a stronger acid than phenol. So CN minus is a weak acid than phenoxide. So this guy wins as a stronger base. Let's switch to Kw. Kw is called ion product constant, or the topic is under equilibrium expression of water. Remember, water is amphoteric, means it acts both as an acid or base. I also highlighted that anything with a liquid or solid does not, again, liquid and solid does not show up in Kw or Ka or Kb. So in this case, we only have H3O plus times OH minus. I hope you can see this color. You can use this property to decide whether a solution is neutral or acidic or basic. If the concentration, by the way, sometimes this is written as H plus times OH minus. They're pretty much the same. This is proton, this is hydronium ion. So if the solution in neutral solution H plus is equal to OH, they are equal to each other. Acidic solution, as some of you might have guessed, H plus is greater than OH minus. And then basic solution, H plus is less than OH minus. In the next session, we will discuss how to calculate pH, pOH, and using H plus and so forth. Of note, at 25 degrees Celsius, Kw is 1.0 times 10 to the negative 14. So you can easily write, I've written it down in here for you. Oftentimes the student don't pay attention that this has to be at 25 degrees Celsius. At 37 degrees Celsius, the body temperature Kw rises, go up. So 2.42 times 10 to the negative 14. And if you want to calculate the pH, by the way, this one at this pH, at this temperature, 25 degree pH is 7, whereas in this case pH would be 6.81. The way you calculate this is if you want to find hydrogen concentration, you take a square root of 2.42 times 10 to the negative 14. And I have the value here. Hydrogen concentration is 1.56 times 10 to the negative 7. And if you want to find pH, we'll go over this later on, minus log of H plus, which is 6.808. If you round it up 2 digits, usually pH is denoted by 2 decimal point, which is 6.81. Once again, at 25 degree, Kw is 1.0 times 10 to the negative 14. As temperature goes up, Kw also goes up. So I hope you find this useful. Thank you for your attention, and I wish you well.